Good morning, my lovely students. How are you doing? How is everything with you? I hope you are fine. I welcome you especially to this online class. This class is for JSS3 Basic Technology, and your topic is Basic Electronics 2. I remain your lovely teacher, Mr. Samson. Okay. Last week we treated Basic Electronics 1, where we had a discussion on emission theorem, how to release electron from a conductor material. We also looked at different electronic components ranging from vacuum tube, electronic valve, triode, that which is also used as rectifier, okay, and gas discharge tube. And now this afternoon we are continuing with the electronic components. That's why we have it Basic Electronics 2. And what we are going to discuss this morning are as follows. Okay, transistors. That's what we're going to look at. Transistors. We say that a transistor is a three-terminal device in which voltage applied to one of the terminals can control current that flows across the other terminals. Okay? A transistor has three terminals. A transistor has three terminals. And any current applied to one of the terminals, which is usually called the base, or you call it the gate. Either you call it base or you call it base. In modern application, we call it base. We call it the gate rather. All right. Can control current that flows across the other two terminals, which are called the collectors and emitter. Collectors and emitters. Okay. The base, I've told you, is also called the gate. Collectors are also called the drain, while the emitters are also called the source. Then, any voltage applied to any of these terminals controls the current that flows across the other two terminals. Okay. Then, we say that transistors are smaller than valve. You remember, it is also coming from the valve family of vacuum tube. Okay, but here it is smaller, quite very smaller. It is an improved valve. Let me put it that way. It is smaller than valve, and it has a longer lifespan and do not require heating as a source of energy, since they need no filaments. You remember that last week in all the 4 electronic components we discussed, 4 of them had source of heating. Because why? They had filament. Okay, the vacuum tube had a source of heating. The diode has a source of heating, or requires a source of heating. Okay, the triode also requires source of heating. Even the gas discharge tube, okay, also has a source of heating. But in this case of transistor, it doesn't require any source of heating, because it doesn't need any filaments. Okay, we also say that transistors can be operated in almost all positions. Do you know what that means? It means you can supply in voltage through any of the terminals. That's it. Okay, so transistors respond faster to input signals, as such appliances that use transistors start working as soon as they are switched on. Okay, now it is not like in the case of valve, electronic valve, where you need to heat up. So you need to the system needs to heat up in order to discharge electrons before whatever you are working on will start working. Since this one doesn't need any heat up, and it responds very quickly to electrical signals. Okay, so any appliances equipped with transistor immediately starts working as soon as you put it on. So it doesn't need to start heating up for 1 minute, 2 minutes before it starts working. No, that is why most of our electronic gadgets these days start working immediately you put it on. Alright, immediately you put it on. So that is it. Now, transistors are made of semiconductors such as germanium and silicon. Semiconductors, we're also going to talk about this, okay? But just know that germanium and silicon are the major things we use for making transistors. Transistors, nowadays, the vacuum tubes are replaced with transistors. Nowadays, vacuum tubes are replaced with transistors because the transistors have more benefits over vacuum tubes, which I have mentioned earlier. The outstanding feature is that it doesn't require a source of heating. That source of heating is extra cost. Are you getting me? It doesn't require source of heat because it doesn't need filament for it to work. Okay. Now, we say that transistors are smaller in size, so it occupies just small space, and it requires low voltage for operation, and also it has low power dissipation. Now I'm explaining these three things we have mentioned there. Smaller in size means it will take small space in your circuit board if you are constructing. Requires low voltage means that no matter how low your volt is, it can input can take in current, and then give it out in a large voltage. Okay, it doesn't give out heat. It doesn't give out heat. Are you getting me? It does not give out heat. So due to these reasons, the transistor is used in many applications such as amplifier for your audio. Okay, audio, you know, those amps that are used to connect with speakers, where you plug in your microphone and start speaking to the loudspeaker. Are you getting it? Amplifiers, switching circuits, oscillators, and also in almost all electronic circuits. That's transistor for you. Okay, this is the image of a transistor. Okay, this is the image of a transistor. We have different types of transistors. As you can see here. All right, we have the NPN transistors. We have the PNP transistors. I will leave you to find out this. It's already in your assignment. We have also other different types of transistors. Okay, so this is the image of a transistor. When you look at the three terminals, emitter, the collector, and the base. Okay, we'll look at the picture here where it is used in the real application. Then this is the representation. This drawing here is the representation. Wherever you see this type of drawing, you know that they are talking about transistors. Okay, that's it. Now we have semiconductors. Semiconductors as the second electronic components we'll be talking about. Semiconductors are those materials whose ability to conduct electrical current is in between that of metallic conductors and non-metallic conductors. What do we mean by that? Semi means it's not actually conductor like metallic conductors, and it is not also a poor conductor or an insulator per se. It still allows current to pass through it, but not as a metallic conductor. Are you getting it? That's why we call it semiconductor. These ones, they do not conduct electricity in their pure state. So they have to be made impure. They have to be before they are actually allowed, before they can actually conduct electricity. You understand what we're saying here? So that is it. Okay, now we say that the two frequently used semiconductor materials are silicon and germanium. I've told you before, silicon and germanium. I hope you grabbed what we mean by semiconductors. There are those materials that cannot conduct electricity in their pure state. They have to be made impure, which the word we use doped with impurities, have to be made impure in order to conduct electricity. Okay, though they do not conduct electricity in their pure states. All right. Then these are examples of semiconductors. We see semiconductors everywhere, every time. Okay, when you open any of your electronic gadgets, you see it there. They are there. All right, they are there. So this is how it is. This is how it is. All these things you see in your radio, your television, when you open them. Okay, so that's it. Then the third one we're going to look at this morning is integrated circuits, IC. Integrated circuits. So these are small microchips that contain a large number of electrical connections and perform the same functions as a circuit made from separate parts. It contains an entire electronic circuit complete with transistors, diodes, and other elements, all photographically etched into a tiny piece of silicon. Okay, integrated circuits is a small microchip. It's very, very small, but it contains a large number of electrical connections and perform the same functions as a circuit made from separate parts. I don't know whether you get circuit made from a separate part. Circuit made from a separate part means that you have different of the components outside, okay, in the separate positions. But in the case of integrated circuits, all these components are inbuilt, are etched into this small microchip. You know, I have mentioned two strange words, doped. One is doped and the other one is etched. Okay, etched into a small microchip, as small as, even smaller than your memory card. Are you getting it? Even smaller than your memory card. So some of them very, very small, but they have different components. All these components, most of these components we are talking about, it contains an entirely electronic circuit complete with transistor, diode, and other elements. So imagine what it would be like. All these things we are talking about are all photographically etched. What we mean by etch, it means engrave on top of a tiny piece of silicon, as the case may be. I hope you understand it now. So integrated circuit is a combination of different other electronic components, okay, made into a small microchip, of maybe silicon or germanium, as the case may be. All right, so that's it. Then also we have integrated circuits are the building blocks for the modern electronic devices. So you must be hearing all these electricians and radio mechanics mentioning IC. Even your phone has IC. Your charger has IC. Anything you're talking about electronics these days has IC. Now, IC are very, very important because they are the building block for the modern electronic device, such as your handsets. If every part of your handset has IC in it, your charging point has charging IC. There's IC that makes your charging port to work. The voice that you are hearing from your earpiece has IC, different IC. The microphone that you speak to in your phone has IC. Are you getting it? The screen coming up, the displaying of picture has a different IC. So inside it there are several ICs which makes different parts of it to function normally. The same thing goes to your computers, your televisions, your home theater. Your home theater, if the sound IC is destroyed, it will be bringing light, but it will not produce any sound. That means the sound IC is destroyed. If the power IC, because the power also has IC, if the power IC of your home theater or your DVD player or whatever is destroyed, it means it will not power again. It will not power again. So IC, that's why we say that IC, that is integrated circuit, is a modern building block. It is a building block for modern electronic devices. Are you getting what we're saying? That's it about IC. If you look at some of them here, look at the pictures of IC. This is it. When you open different electronic devices, gadgets, all these things are what you see there. All these things are what you see there. These things, they have the different functions. And remember, as small as they are like this, they have diode in them, they have transistor in them, and many other electronic components. Okay, all right, we are almost coming to the end of this class. I hope you enjoyed the class. A recap of what we treated today: basic electronics 2, where we talked about a transistor. We say that a transistor is a 3-terminal electronic component. Okay, a 3-terminal electronic component. The 3 terminals are the base, which we also call the gate, the collector, which we also call the drain, and the emitter, which we also call the source. It is used over electronic valve, which is the diode, because it has a wider range of benefits over electronic valve. Okay, it doesn't need heating up, it doesn't have filaments, and it doesn't consume much power. And again, it doesn't take much space, and it doesn't give out heat. That is why most of our modern electronic devices these days, they don't heat up like olden days. Olden days electronic devices that are built with a valve and vacuum tubes. Are you getting it? So they don't heat up because of these components that are used. We also talked about semiconductors. I told you semiconductors are those materials that do not conduct electricity in their pure state. They have to be doped with impurities. They have to be made impure. They have to be combined with some other elements or material before they can conduct electricity. All right. So we also talked about integrated circuits, ICs. I told you that ICs is a small microchip that has many electronic components embedded in it, as small as it is like that. Okay, I told you that it is the building block for modern electronic devices. Almost everything you have, every electronic device you have in your home, in your hand, have ICs in them. All right, several ICs, not only one. I give you example. Your handset is made of the charging point, the earpiece where you hear the person's voice, the mouthpiece where you speak so that other will hear you, the power displaying picture. Okay, all these things have different ICs that control them, that make them work. Okay, so that is it. Now that's bring us to the end of this class. Thank you very much for being part of this class. And this small thing here is your assignment. Please, I'll be expecting it. Assignment number 1. Write the full meaning of the following. Full meaning of the following. Full meanings of the following. NPN transistor. You need to tell me what that means. PNP transistor. BJT transistor. FET transistor. And then JFET transistor. Number 2, draw the diagram of an N transistor. So I gave you this type of assignment so that you don't just depend on what I said here. Go and consult your textbook. And find answers to this. If they are not in your textbook, grab that your phone you are using now and enter Google. Find their meaning. Thank you once again for being part of this class. I remain your humble teacher, Mr. Samson.